All right, back for part two. Before we move on to or example two rather, one thing you might be thinking is, where would they get this function? Maybe it fits perfectly. Maybe this is exactly what happened in Brighton in 1900, but how would they know this is the function? Well, I mean, there's ways to do this. And one of the ways we saw earlier when we did exponential functions, and then again when we did um, before that when we did trig functions, is using the calculators to do regression. So this is example two now that has years and cancer incidence. The idea here, the incidence of lung cancer in Canadian males is shown in the table. So this is the idea of in 1975, 73.1 people out of 100,000 in Canada, Canadian males, had lung cancer. Okay, and they want us to use regression to determine a cubic function. The steps that I do are going to be over here. Do not be afraid to ask about this. Do not be afraid to look up in online about how to use the calculators, or there's help videos all over the place, and of course, you can pause. It's almost a good idea to have one of the calculators, or at least the emulator, next to you while we're going through this. With that said, I'm going to try and go through it pretty quick because we've done it a few times. Um, there are the steps there. You can pause the video and copy those down. I'm going to put my calculator right over them right now. No, I'll leave it over here. Um, what I did do to speed up the process a bit was I put the data in already. So stat 1 is to enter, and I entered the data. Notice I didn't put in 1975. I pulled um, this trick that they pulled in the last example where 1900 was 0. Well, this 1975 is 0. So in list 1 is the years since 1975, and then I put the cancer incidence in list 2. And so the next thing that I can do is set up a plot. So second y equals sets up a plot, and notice all my plots are off. So I want to turn one of them on and make it a scatter plot. List 1, list 2, all this is going to be good. And then this next part is to actually do the cubic regression. So I hit stat, I go over to calc, and we've done all sorts of regression, linear regression, quadratic. This is cubic regression they're suggesting. So I'm going to select that. And then remember, I need to put in all this other stuff in order for the regression curve to show up. So list 1, second one, and then comma button. List 2, comma, and the y1 character is the one that'll actually help us graph the curve of best fit. And there are the steps. And here I go. Vars over to y vars 1, 1. We'll actually put that in there. Now the command's it's waiting to be entered. Bam, there it is. And it's nasty. I realize that. I'm going to take a screenshot of it and then paste that in here. And then we'll interpret what the heck that means. Okay, well, this is telling us that the cubic function has this form, and we kind of saw that. That's looks like a polynomial function. Well, it is degree 3. And it's telling us what the values of A, B, C, and D are, right? So the curve of best fit here, A is 0.0014 x cubed. The B is negative 0.162 x squared. The C is 3.39, and I can put as many decimals as I want, but I'm kind of rounding off a little bit, plus 72.4, say. Okay, and say, so, well, where did they get that Brighton's population function? Well, maybe they used a TI-83, not 1900 they wouldn't have, but maybe that's whoever was analyzing the data got it. And so in part B, oh yeah, let's have a look at it. And to have a look at it, Zoom 9 sets up the window settings for us automatically. Zoom 9, Oh, lovely. It looks like it could have been a parabola. Why they picked a cubic, who knows? That looks like a parabola. Maybe it's sort of not going quite as fast this way, but it looks like the cancer incidence have went up, and then maybe sometime in here, who knows what date that was, it starts going down. Okay, um, dandy. They weren't asking us to graph it or to sketch it, so that was bonus learning for you. Fantastic. Uh, Predict the cancer incidence in 2015. Well, that's 40 years from now, so that's x equals 40. So one thing we could do, and we've practiced this, is grab this 40 and jam it in this nasty function and then just press equals. That's possible. And I'm not going to do it that way because I don't want to have to type all that junk out again. It was bad enough writing it. The calculator can do this for us, okay? And that's one way that it was nice to graph it. So on the graph, if I press trace, notice right now I'm on the plot. I got to jump up to the line, and now I'm on the line. I got to look for 40, right? And if I type in 40, which I'd love to do because it would jump right there, it says it's invalid. It's invalid because the window settings only went up to 2000, right? This is 2015. If I type quit and then window settings, if I change this so it's over 40, then I'll be golden. And go up by every 10 years, I'll put a tick here. Then I press graph. It looks like it's going in the negatives, but remember the scale's all goofed up. So let's hit trace, jump onto the function, and then now I'm going to type in 40, and it's 38.9. So the y value is 38.9. So I'll say from the TI-83, the incidence rate will be 38.9. And that's people per 100,000. It's going down, right? And that's what the prediction shows. Discuss what the domain could be for our model. Well, we know these polynomial functions, they go on forever, right? So this one is got a positive leading coefficient, so it starts low and ends high. You know what's going on here? Did it go low and then it's going to go back up again? Like what part of the graph are we looking at? So what is the domain for this model? For what years is it okay to use this model to make predictions? Well, that's a good question. How I'm going to answer that is kind of zooming out on this and see what values might make sense. Certainly from 1975 to 2000 would make sense because that's these dots. Even this one makes sense. It would make sense that cancer is going down. But I'm going to change the windows and zoom out a little bit here. Say over the next 100 years. Is it going to be okay over the next 100 years? Well, maybe not. And I'm going to go down right to 0 because it doesn't make any sense for the cancer rate to be negative. So I'm going to put in a little bit like that. Maybe yeah, up to almost 100 people might make sense. I don't know if it's going to go back up or not, but let's graph that and see what's going to happen. There's our data, and then it's going to keep going down, and then start being negative, and then it's going to go back up the cancer incidence rate. So what's the domain? Well, we can see probably that anything like it can't be negative, so that spot right there would be our cutoff. But it might be someplace in here where we just think, at some point it doesn't make sense that the cancer rate's going to keep going down. Certainly, maybe it could be at 0, right? And I can use my graphing calculator, my model, to predict when the cancer rate might be 0. It doesn't make sense for it to start going back up unless something awful happens and we find new types of cancer that we didn't have a cure for before. But let's see if we can find out what year that was where that has an incidence of 0. Well, let's do the 0. I'm going to make sure I'm to the left. Yeah, I'm positive y value there, and I'm going to scroll to the right so I get negative y values. kind of hard to see. And then I'm going to go back and have a guess. So incidence is 0 when X was 50, almost 57. So 57 years from 1975 is around 2000 and what's that? 2032. So does it make sense that our model, the domain might be, because the model started in 1975, one could argue that maybe we can go back further than this. Maybe it started in 1960, and if we looked at the graph and went back a few years, maybe, you know, I could go back 20 years and see, you know, does it make sense in here in 1968? Well, who knows? I think we'll start at t equals 0. That's when our data started. We might say that till 57 it makes sense, and that's 2032. But one might also argue, you know, after a certain spot, maybe after here, that the model doesn't make sense anymore. You know, and then this is a little bit of an opinion, right? It's an argument. Might be the domain, and I'll add, but this is debatable. Okay, that was a good fun question. Not often lung cancer is fun, but I think it was there. That's it. Good luck with your homework. Thanks for stopping by.